Before class assignment number 10, CAD strategies, top-down modeling. To get 10 points for this assignment, watch both YouTube videos, including the video demonstrating the fire piston in action at a scout campout, and this video demonstrating how to model it within the context of the assembly. You're also required to design this fire piston using this top-down strategy. And make sure that the size of all the components update automatically as you change the size of even one of them. And I've selected an O-ring that will work with this application. This O-ring here is a -10. It's a nominal width of 1/16 of an inch, which actually is 70 thousandths wide. So let's get started. The first thing we do in Inventor is make sure we have a project created to organize our work. I've created one, BC-10 CAD Strategies Top Down is what I've titled it. And I'm going to create now a new part. I'm going to model all of the components of my assembly in this one part file. So let's start with the piston. I'll model the piston of a 3/8 inch diameter, and we'll extrude this by 3.5 inches. Let's now create, we'll go into the Manage tab into Parameters. This is something I wanted to show you. Every time I do modeling, a sketch or an extrusion, the parameters that define that are created as variables, variable parameters. This dimension D0 is the 3/8, which is the diameter of the piston. This dimension D1 is the 3.5 inch length of that piston. So I'm going to give these, I can give them a different variable name. I'm going to give this one a name, piston diameter, so that I can access it easier later on. Let's now create a hole, a concentric hole on this plane, concentric to this cylinder. We'll go 1/4 inch diameter, but only 70 thousandths deep. That'll be the pocket for my char cloth. I'll create some thread instead of a full length thread, only a partial length, and I'll create it on this end, 3/8 of an inch. There's the thread. And let's go back into this parameters, and we'll notice that sure enough it's creating more parameters. This 3/8 inch dimension D12 is the thread length, so I'll give that a name that's a little bit more intuitive, called thread length. I'm going to be accessing that later. Alright, let's go ahead and now create a sketch on this plane. And we're going to make the O-ring grooves. There's an O-ring, and let's make the grooves for the O-ring, a couple rectangles, and we'll make the O-ring grooves equal width and equal depth. And let's also make the tops of the O-ring grooves flush. We'll make the O-ring groove tangent to the O-ring on both sides, as well as on the bottom. And let's specify a diameter of this O-ring as 70 thousandths. And let's specify the depth of the groove as 85% of the diameter of the O-ring. Notice the formula that I'm using, so that now the groove depth allows 15% of the O-ring to stick out beyond. That'll help me give a good seal. And let's specify the distance between grooves as the same as the O-ring diameter. And I'll project the edge and this edge of the piston so that I can dimension to the end, and we'll make this 2 times the O-ring diameter from the end. And we will make the O-ring groove down flush with the edge of the piston. Now we can do a revolve, and we'll revolve both of these rectangular profiles about this axis, and we will subtract. There's my grooves. I'll go ahead and make a chamfer now on this corner. We'll make it a 30 thousandths. That'll get rid of burrs on this end. Okay. Now I'm going to go ahead and create an O-ring. I've noticed that this sketch number 3 is where I defined the O-ring, so I'm going to share that sketch so I can access it other locations, and we'll revolve this circular profile around this center axis. But notice I'm going to not leave this button pushed in. I don't want that O-ring to be fused to the existing solid. I want to create new solid. So now we'll notice up here under solid bodies it's showing me 2 solids. I'm going to rename them just so that I am clear of which solid is which. This solid number 1 is the piston. This solid number 2 is the O-ring. Okay, so I've created my piston and the O-ring. I'm going to create a few datum planes to help me define different aspects of the body. I'll put a datum plane here, right at the end of the piston. That'll represent the bottom of the hole that's in the body. I'll create a datum plane that's about 1/4 inch away. That'll represent the bottom of the body. I'm going to create a datum plane here that's at the thread length away from the end. That represents the bottom of the thread. And I'll create another datum plane about 1/8 inch away from that. So that will be the top of the body. So the body will go between those 2 datum planes. Let's create a sketch on this plane. And we'll sketch a circle. And we'll make this body out of 3/4 inch stock. Fully constrained. So let's extrude this, and we will go until we reach this datum plane. So our body is that long. And now let's create a hole in the body. Actually, one thing we want to make sure of, if you notice, when I created the extrude, I left this button pushed. Shame on me. That's going to fuse the body and the piston together as one solid. I don't want that. I want to create new solid. So I'll do that, and notice I get a new solid up here. Let's go ahead and rename it as the body. And now we're ready to create a hole, concentric hole, on this plane, concentric to this cylinder. And we'll make the diameter of this hole the piston diameter plus some clearance. We'll go 15 thousandths clearance. And the distance of this hole will go to the datum plane that we've created here. So that's how deep the hole will go. Alright, so now let's put a few fillets on the sharp corners, 1/8 inch fillets, and now our body is completed. Okay, now we're ready to model the cap. Let's create a sketch on this plane. We're going to project this edge onto that plane. We'll finish the sketch and we'll extrude that profile. Let's extrude it this direction, and let's go 2 times the thread length. That's how big our cap will be. And if you notice, I forgot to say I'm creating new solid instead of fusing it to the existing. And we'll notice that, yes, it gives me a new solid here. So we'll call this cap. And let's create a hole. We'll create a concentric hole on this plane, concentric to this cylinder. And I'm going to create a threaded hole, and we'll make it a 3/8 16 UNC thread. And the depth of this will be the thread length plus, let's go an extra 1/8 of an inch to make sure we're drilling deep enough so that our threads won't bottom out in the hole, but rather the cap will bottom out on the threads. Okay, and we'll go ahead and round these corners with the fillet. Okay, so we have all of our components modeled now: a piston, an O-ring, a body, and a cap. So let's go ahead and save this. And notice I'm going to name this something very interesting. I'm going to name this Fire piston layout. So this lays out all the parts, sizes, and shapes. And so I call it a layout. And I save. Now I'm going to go to this Manage tab, and I'm going to go to this tool called Make Components. This tool will allow me to make a separate part file out of each of these solid bodies. So I'm just going to window around all this, and each of these solid bodies, notice the piston, O-ring, body, and cap are selected. And I want to make a separate file out of each of these, and I want to insert them into an assembly that I'm going to call Fire Piston Assembly. And it'll use this as the template for the assembly and save that assembly file in this folder. And we'll hit OK. Okay, so we'll notice now that we have our fire piston layout part, and now it's made a separate assembly, fire piston assembly. And it's placed each of these solid components in it. And it's actually grounded each of them. I'm going to unground the piston, unground the O-ring, and unground the cap. We'll leave just the body grounded. So now we can grab these items. We want to be visible the piston, just not grounded. So we can grab all of these items and move them out of the way. We'll grab the O-ring and move it out of the way as well. Now we can go ahead and just apply assembly constraints as we normally would. So let's create a constraint. We will place this center axis on the center axis of our piston. Let's create a tangent constraint here up against this face. We could even place another O-ring. I think we're going to have to save this. Let's say yes to all. And let's place another O-ring. And we'll do the same thing. We'll place the center axis here, and we'll create a tangent constraint up against this face. So we've placed both O-rings now. Now let's place the cap. I'll constrain this. Let's make an insert constraint. We'll place this here, and let's give it a distance of 3/8 of an inch. Actually, we needed that distance to be -3/8 of an inch, so let's make that a -3/8 of an inch. So we've inserted that to the bottom of the thread. And now let's make this axis and this axis aligned with one another. And now I have my piece that is constrained the way I want to, and it's sized correctly. So I'll hit save on this. Now here's the test, the real test. If I go back to this layout model where I modeled all the pieces, let's go and change the length of this piston extrusion and see if everything updates accordingly. Let's change it to something drastic like 7 inches. Notice I changed the length of the piston, and the length of my body also adjusts. Okay, now if I go back to the fire piston assembly, we'll notice it still looks short. So what I've got to do is I've kind of come to this Manage tab and say, well, let's update the assembly because I've made some changes in the components. Let's view this, and we'll view a section view. Let's look at some datums as well. I better take a look at some of these datums. Let's make these visible. And let's make a half section view on this plane. And we can make those invisible. And we can see, if we zoom in here, that I have the O-rings in the grooves, and I have the piston that's also adjusted in length. So I made one length adjustment. The piston and the body grew accordingly. Okay, so Make sure you test yours to see that if you change the length of the piston, the body also grows. And that's the end. We'll see you in class.